Hi students, today we are going to discuss the principal foci and the focal lengths of a biconvex or biconcave lens. First we come to the principal foci. So a biconvex lens, that is a converging lens, or a biconcave lens, that is a diverging lens, both have a first principal focus and a second principal focus. Now which is the first principal focus? For a converging lens, what we call a converging lens, that is a biconvex lens, has a focus on either sides of it. Now which one is the principal focus here? The one here or the one here? So a point such that a ray passing through this point will emerge parallel to the axis. So the point on the principal axis, so that the ray passing through it will emerge parallel to the principal axis. That one is called the first principal focus. So here F1 is the first principal focus, and this distance small f1 from capital F1 to the lens is called the first focal length. Now the first focal length for a converging lens is negative, because we know the object is kept on the left and distances on the left are considered to be negative. So I hope it is clear. The first principal focus for a converging lens is that focus or that point such that a ray passing through it will be incident on the lens and it will emerge parallel to the principal axis. Okay, now the same first principal focus how will it be for a diverging lens? How do you define it for a diverging lens? Now for a diverging lens, it is the point through which the ray would have passed in the absence of the lens. So a ray is coming like this. If the lens is not here, it will pass like this. But because the lens is here, the ray will undergo refraction and it will emerge as parallel to the principal axis. A ray which in the absence of the lens will converge to a particular point on the principal axis, but because the lens is present there, it will undergo refraction and go parallel. So that ray, when you extend it backward, it will hit the principal, or it will coincide with the principal axis at a point called capital F1. So this capital F1 is the first principal focus for a diverging lens, and this length F1, small f1 here, that is the distance between the lens and the first principal focus, is called, here also it is called the first focal length. But the difference is, for a diverging lens, the first focal length is positive, because the object is on the left, distances on the left are considered negative and that to the right are considered positive. So I hope first principal focus and first focal length is clear to all of you for both converging as well as diverging lens. Now what is the second principal focus? That too firstly for a converging lens, that is we consider a biconvex lens. So the point at which a ray traveling parallel to the axis will intersect the axis. This is a ray traveling parallel to the, I have forgotten the arrows here, please do draw it. So a ray parallel to the axis will converge to a point on the principal axis. So this is a ray parallel to the principal axis, it will converge to a point. So this focus is called the second principal focus. Okay, so the second principal focus is at a distance small f2 from the lens, and this distance small f2 is called the second focal length, and it is positive. For the converging lens it is positive because it is lying on the right of the object. If this is the object, then it is lying on the right side. So what is this second principal focus? It is the point to which a ray parallel to the principal axis will converge after refraction, or it will intersect the principal axis after refraction. So that point is called the second principal focus. Now, how do we define it for a diverging lens? It is the point where a ray parallel to the principal axis would have intersected the principal axis if it were produced backwards. So a ray parallel like this would diverge out from the diverging lens like this at the lens surface. But if this ray is produced backward, then it will hit the principal axis at a point, and that point forms the second principal focus. So, second principal focus, in both the cases, we first consider a ray parallel to the principal axis, and where does it touch the principal axis? That point forms either diverge to or converge from. That point, diverge from or converge to. That point is called the second principal focus. So I hope the second principal focus is clear to all of you, and the distance between the lens and this focus, second principal focus f2, is called the second focal length, small f2. And here for the diverging lens, the second focal length is negative because the object is on the left, and second focal length is a distance on the left of the lens. Now, for a thin lens placed in a medium, now this is a thin lens, we have not considered the thickness of the lens. If the refractive index of the medium on both sides, so here on one side of the lens you have N1 as refractive index, the other side N3, and the refractive index of the material of the lens is N2. If N1 is equal to N2, that is throughout you have a common medium, then F1 and F2 can be very easily obtained as 1 by F2. This is a converging lens. For that, the second focal length F2 is positive. So in the last class we had written 1 by F is equal to N minus 1 into 1 by R1 minus 1 by R2. So how do you calculate the second focal length and the first focal length here? 1 by F2, it is positive. 1 by plus 1 by F2 is equal to minus 1 by F1 is equal to N minus 1 into 1 by R1 minus 1 by R2. Now, if a thin lens is placed in a media such that N1 and N2 and N3 are not equal, that is on either sides of the lens you have different media, then the equation is changed as N3 by V minus N1 by U, that is where you get the image, that is that medium is N3 by V, where you keep the object, that is N1 by U, is equal to, initially it was N2 minus N1 by R that we write, or here it is N2 minus N1, that is second medium minus first medium by R1 plus third medium minus second medium N3 minus N2 by R2. This is how the equation changes. So when U is, that is the image is formed at the first principal focus, that is at F1, that means if the object is placed at the first principal focus, U is equal to F1, then V equal to infinity. If the object is at the focus, V is at infinity. So that our equation 1 becomes, that is equation 1 means the one that we just wrote down, this one. This equation becomes, object is at the focus, so it is minus N1 by F and N3 by image is formed at infinity. So V is equal to infinity. So 1 by infinity is 0. So this term cancels out. Minus N1 by F1 is equal to N2 minus N1 by R1 plus N3 minus N2 by R2, or minus 1 by F1 is equal to 1 by N1 into N2 minus N1 by R1 plus N3 minus N2 by R2, or 1 by F1 is equal to minus of 1 by N1. I just rearranged this, that's all. Okay, because thus we can determine the first principal focus. Understood? So how do you consider? ഒബ്ജക്റ്റ് ഇരിക്കുന്നത് ഫസ്റ്റ് പ്രിൻസിപ്പൽ ഫോക്കസിലാണെങ്കിൽ ഇമേജ് ഉണ്ടാവുക ഇൻഫിനിറ്റിയിലാണ്. അപ്പം നമ്മൾ ഈ എഴുതിയ ഇക്വേഷനിൽ ഇവരെ സബ്സ്റ്റിറ്റ്യൂട്ട് ചെയ്ത് കഴിഞ്ഞാൽ, അതായത് ഇതിന് മുന്നേ എഴുതിയ ഈ 1 എന്ന് പറയുന്ന ഇക്വേഷനിൽ സബ്സ്റ്റിറ്റ്യൂട്ട് ചെയ്ത് കഴിഞ്ഞാൽ നമുക്ക് 1/f1 is equal to 1/n1 into n2 minus n1 by r1 plus n3 minus n2 by r2 എന്ന് കിട്ടും. അതിൽ നിന്ന് ഫസ്റ്റ് പ്രിൻസിപ്പൽ ഫോക്കസ് നമുക്ക് ഡിറ്റർമിൻ ചെയ്യാം. Now how to determine the second principal focus? So if the rays are parallel, initial rays are parallel to the principal axis, that means u is equal to minus infinity, then v is equal to, then the image is formed at the second principal focus. We know a ray coming parallel to the principal axis converges to a point on the principal axis. If this is my principal axis, then a ray coming parallel to it will converge to a point on the principal axis, and this is my second focal principal focus f2. Now how do I determine this second focal length small f2? For that I consider my u equal to minus infinity. Why minus infinity? Because it is a length taken on the left hand side. So u equal to minus infinity, v equal to, it is formed at this focus, so v equal to f2. Again substituting in equation 1, you get 1/f2 equal to 1/n3 into n2 minus n1 by r1 plus n3 minus n2 by r2. So I hope how to determine the first principal focus and how to determine the second principal focus is clear to all of you. We just place a lens with a medium n1 and n3 on either sides of it, and you just apply the equation directly. We come to the last section of this chapter, that is lateral magnification. Lateral magnification m dash is the ratio of the height of the image to that of the object. Height of the image, if y dash represents the height of the image and y represents the height of the object, then magnification m is equal to y dash by y equal to v by u is equal to f2 plus x2 by f1 by x1. That is equal to minus f1 by x1 equal to minus x2 by f2. So how do we get that? How is the proof done? So we consider a biconvex lens. You have an object here of height y. A ray parallel to the principal axis goes through this second principal focus, and a ray through the center of curvature will go straight. They coincide and you get the image here, and the image height is y dash. Now you consider these two triangles, that is BOC and IOICM. You consider the triangles, this small triangle here BCO or BOC, and the triangle here that is MIC. Now these two triangles are similar because this angle is 90 degree, this angle is 90 degree. These two angles theta here are equal because they are vertically opposite angles. If two angles are equal, naturally the third angle will be equal. So by AAA similarity, these two triangles, that is BOC and MIC, are congruent, similar. So we can write down OB by OC is equal to MI by IC. OB is y and OC is u. Y by u is equal to y dash by this total distance is v. This is v here. So y dash by v. So when you rearrange, what do you get? Y dash by y, that is magnification, y dash by y is equal to v by u equal to f2 plus x2 by f1 plus x1. How did I get that? Now my u is equal to first focal length plus x1, and v is equal to second focal length f2 plus x2. So I got m is equal to y dash by y equal to v by u equal to f2 plus x2 by f1 plus x2, which is the magnification. So I hope this session is clear to all of you. If you have any doubts, please do contact. Thank you.